was recently asked about tool creation tips in Unity. So in this video, I wanted to walk through an example of creating a basic tool for manipulating a path. It's not so much about the path component itself, but more about the steps and thoughts that go into creating a basic tool for it. By the end of this video, you'll get to create a path with points, draw that path in the scene view using Gizmos, move the points on that path using handles, perform undo redo queue on the changes you make, then improve the way the handles work in a more advanced option setting. Even if you're fairly experienced with Unity, hopefully something on here will pique your interest. So without further ado, let's get to it. The first thing we're going to do is create a path using some points. So let's create a folder, we'll call it scripts, and then within that folder we're going to create a C# script and we're going to call that path. Let's open that up in Visual Studio. Here we go. Okay, so the first thing we want to do is get rid of some of this because we won't be needing it. There we go. Actually, in fact, we'll get rid of all of it because we won't need any of that at the moment. So I'm going to start the path with some control points. So let's create a serialized field. Create a tooltip. Control points for the path, and then we'll just use an array of vector threes. And we'll call them control points. There we go. Okay, and then we're going to draw these control points, and we're going to use the Gizmos option for this. So on draw Gizmos is the function, and within here we'll check whether we have control points to start off with, because if we don't, then let's not bother. So let's just return on that. And then we'll iterate through those control points. But we're going to draw lines between them. So we want to keep the previous point, and then if we've got 2 points, we'll draw a line between them. So let's start with creating a nullable vector 3, and we'll call this the previous point. And we'll set it to null. Now we'll create a for loop to iterate. So int I equals 0, I is less than the control points dot length, and then we'll iterate up. There we go. Okay, so we want to get the current point we're on. So vector 3 point equals m control points I, and then we'll take next point. So if previous point dot has value, then we'll actually draw this. And we're going to draw this in white, which is the default color, but we're going to be adding some extra items to it in a minute. So we'll start off with white. There we go. And we'll draw a line. So gizmos.drawLine, and we'll draw it between the 2 points. So our previous point dot value and our current point, which is point. And then we'll want to make sure we set the previous point to the point, because then it can draw between them. So let's save that and jump back into Unity. And in our scene here, we'll create an empty object and we'll call it path. And we're going to reset this. So make sure it's at 0, 0, 0. Get the camera nice and neat. And we'll add our path here. And then we'll start adding some control points. So let's add 3 control points, and we'll do 1 there, 1 there, and 1 there. There we go. And if I focus in on this item and I get rid of the move, you can see there's our path. Let's make it a little bit bigger so we can see it easier. There we go. So 5 up, and we can move it around, and there we are. There's our path. Okay, so there's a problem with this. If I go to actually move my path about, you'll notice this path doesn't actually move as I move the transform. And that's because these points are set in world space, and we don't have them in local space. They won't be transformed by the transform component. And we want to be able to do either, because if you've ever seen something like a line renderer, you'll notice that there's a use world space switch on it that enables you to select either option. And we want to do the same here. So let's reset our transform, and let's go back into our script and make that happen. So we open up our script. In here, we're going to create a flag that specifies that. So tooltip, use world space, and that's a Boolean, use world space. And we'll set that to false as default. Now, in here, we're returning back the control point straight from the array. So this doesn't know about our world space option yet. So what we want to do is we want to make sure that this uses the world space. So use world space. And if it does, well, yeah, we're good. We've already created that. However, if we're using the local space, what we want to do is we want to use a function in Transform called Transform.Point, which will take this control point, pass it through the transform, and give us the result out. And that will give us the point that we actually draw on. So let's save that and jump back into Unity. And we'll go to our path. And now, because world space is off, if I move this around, reselect it. If I move this around, you'll notice it moves with it. If I rotate, it rotates with it. The points are being transformed via the transform and then getting placed in the world. And if I press world space on there, you'll notice it goes back because it uses these directly. So that's ideal. So one of the problems we have with this script is this is all well and good, but changing the actual points in the array to manipulate which points are being shown where, that's just not ideal. We want to have handles on these points so that we can actually move them directly. So let's do that, shall we? Let's jump in. We'll create a folder. We'll call this editor, and we're going to create a custom editor for our path. So let's create a C# script. We'll call this path editor. We'll open that up in Visual Studio. There we go, reload. And we'll be deriving from the editor class, and that comes from our Unity editor library. And we're going to need to set an attribute called custom editor to tell Unity that whenever we select our path component, this is the custom editor script to use. So we'll get rid of the minor behavior stuff. And then we're going to basically set stuff in our scene GUI. So we want to use the onScene GUI function from our script. Now, next thing to do is we're going to want to collect the component because we're interested in the parts of the path. So path equals target, and target is a variable under the editor that basically we can cast a path and get the component that we're interested in. Now we're going to want to iterate through all these points and add handles. So we're going to need to set some functionality in our path script. First thing we're going to do is return the number of control points. So there we go. We'll just return length of the control points array through number of control points. Excellent. And then what we're going to want to do is we're going to want to get each of these control points, but we're going to want to get them in their correct space, whether they're using world space or not, like we did down here. So let's create a function which will return a vector 3, and we'll call this get control point, and we'll need to tell it which index we're interested in. And what we're going to do is we're going to take this functionality here and we're going to return it here. And we're just going to change out the I, the index. And then down here, we'll swap that out with get control point. There we go. Now, because we're creating handles, we're going to want to set these control points back. So we'll need a set function for that. Set control point int index and the position that we've changed it to. There we go. And now, because we're using world space, we're going to want to change this back. We're going to want to invert if it's actually using the local space. So control points index equals. Now, if we're using world space, we're just going to pass the position because it's world space. However, if we're using the local space, we're going to want to use the inverse of that function, and it's inverse transform point. And then we set position there. So like the transform point, it will take the position, it will inverse it through the transform component that we have, and then provide the position we're actually interested in. So let's save our path because we've done our functionality, and we'll come back into here and we'll start iterating through that array. So the number of points, There we go. And we want to put the iterator in. There we are. Okay. Now we're going to want to get the position. So vector free position equals path dot get control point I. That will give us the position. Now we're going to want to create a handle at that position. And Unity gives us this through the Handles.PositionHandle. And we can pass it the position. And we're not interested in that handle being rotated at all. So we'll just set that rotation to be the identity. Now we want to get the handle position back. So if anything's changed, so we'll get a new position back. There we are. And now we want to check whether that position's actually changed. So if position does not equal new position, then we'll set the position. So path.setControlPoint I new position. Excellent. So we'll save that, come back into the Unity editor. And now when we select our path, we have manipulators. And as you can see in the array, as we move it, we make that change. Move this one, make that change. And this is using world space. If we weren't using world space, then this would move as well. Okay, so now the problem with this is if I make that move and I press Ctrl Z on my keyboard, that wasn't correct. It's actually undone the transform that I made on the entire component, not the change I made to this part of the component. And that's because we haven't told Unity about these changes. We haven't put those into the undo redo queue. So let's do that now. Let's jump back into our path editor and use the undo redo queue. Now, the first thing we want to do is we want to check for change. So editor GUI.begin change check. And then in here, we want to see if we've got the end of the change check. Editor GUI.end change check. And now we want to add the undo redo functionality. Now what you have is you have something called undo and record object. We pass that the path and then we give it a name of what this change was. So we can just say change point position, for instance. Now the reason we do that before we make the change is what Unity is doing is it's recording what the path currently is before we make the change. So when we do undo, it just brings the path back to what it was beforehand. And if you had several objects being changed at the same point, you wouldn't write several record objects for that. You can actually use record objects and then pass it an array of objects that have actually changed. Because then when you press Ctrl Z, you're only doing one return. If you record lots of record objects in a row, then what happens is every time you press Ctrl Z, it's just going back over each of those record objects, which would look weird to the user because they only made one change to them, but they're having to go back several times to record that. But let's see what we've got here. So we've got undo record object. We'll come back into Unity. And in here now, if I move one of my items and I press Ctrl Z, there we are. It's undoing it. So I move that and Ctrl Z. So now we have undo functionality on our path. Right, so going back into our script, we can have a look at what we've actually added here. And one of the things we've added is the editor GUI begin change check and editor GUI end change check. Now what this does is it looks at the scene GUI and sees if any of the controls that are between these points have actually been changed, whether we've moved this position handle. And if we've done that, then we've changed the position. So we no longer need to have position does not equal new position. So we can actually get rid of that part of the script because this area here will say begin, end check, whether the position handle's changed, and if it has, then perform this functionality here. So this is a nice, neat way that Unity gives us to check if there's changes that have been made. Okay, so coming back into Unity, one of the problems we have here now is if I turn back on the move manipulator, you'll notice that if I turn off world space, now we've got a problem because our 0 element, array 0, is overlaying the manipulator on top of the move manipulator. And this is even worse if this is at 0, 0 and everything's at 0. Now they're completely overlaid. I can't get to move the manipulator on array element 0. So we'll want to be able to turn on or off whether these are actually displayed. So let's jump back into our editor and we'll override our inspector. And we're going to add a button that turns on or turns off the position handles. So we'll add a flag up the top here and we'll call this show handles. We'll set it to default to false. And if this is off, then what we'll do is we won't perform any of this functionality. There we go. So close it out. Now we want to add a button that enables us to make that switch. So we'll add a button and we're going to take a formatting and first element, handles, and then we're going to want to basically show or hide in a string whether the handles are going to be shown or hidden. So what this is doing is it's basically saying if this flag is set to true, so it's showing handles, then put this string hide in here, otherwise put show in here. That's just a very quick way of not actually having to add two buttons, one with show and one with hide. And then what we'll do in here is we'll just make show handles equal the negative of what it is. So now if I come back into Unity, we can see we've got show handles here. Now it's set to false as default. If I press this, nothing happens until I move into the scene view. Now that's weird, but the reason for that is pressing on this button here does not perform a repaint of this scene view, because the scene view isn't repainting constantly. It's waiting to be told when to repaint, and that's from performing an action in scene view, changing the focus to scene view, etc. in Unity. And this won't do that. So within Unity, within Visual Studio, what we can do is we can add SceneView.RepaintAll. And what that does is it tells all the scene views to repaint. Very simple. Come back into Unity. And now, if I press show handles, it immediately does it. So that's a little handy tip when you're doing your tools, if you're wondering why, when you're pressing buttons, they aren't making the change in the view itself. Now, one annoying thing with this is if I actually want to show the handles or unshow the handles, I have to come over to here. And if I've got other components, this might be further down. So it might be handy to have a quick shortcut key to turn these on and off. So let's go back into Visual Studio and add that. And the way to do that is in our on-scene GUI, we can look for events that have happened. And to do this, we can use the event class and go current. So that will give us the current event that's taken place. Now all we need to do is check that that current event is a key down event, and also check which key has been pressed. Now, currently I don't have B subscribed to anything. I don't have it assigned to do anything. So I'm going to use B in this case. But if you've gone in and you've changed your key codes, you might want this to be something different. And again, we're just going to negate the show handles. So we'll press save. We'll come back into Unity. And now if I'm in the scene and I press B, it turns it on or off, and I don't need to go to the handles. And you'll notice when I come over, the handles button actually changes as I'm pressing. Now the next thought is, if I was designing this tool, this is really busy. Like, why am I showing all of these handles at once? And why am I making the user press or unpress to show these handles? It's an overcomplication that I don't need and I don't want my users to have to do. And also I'm overloading the information upon them by showing all of these handles. If this path, if I was way out here and I wanted to change this path, this becomes a nightmare because all of these handles are showing. So what we want to do is we want to add the ability to select which point we want to then show the handle and be able to move it. That means that the user won't be overloaded and it makes it really easy for the user to show and hide these handles. So let's do that. Let's jump back into our script. And what we're going to do that is we're actually going to add a button at each of these points to enable that to happen. But we won't be needing any of this show handles because, as I said, that's one way of doing it, but it's not the way we want to actually do it. So let's get rid of all this, as we won't be needing that. And now we're going to bring this back, Shift tab it, and let's add buttons to each of those points. So again, we'll want to roll through each of the points we're interested in. There we go. Let's move that back. We'll want to get the position of the point, which is the same as this. And then at each of those positions, we're going to want to add a handles button. So if Handles.Button, set it to the position. We're not worried about the rotation of that button. Now I'm going to set the button here to have a size of 1/4 and a pick size of 0.5. So what that's doing is it's saying how big is the button going to display and how big is the actual pick size around it. And I always make the pick size a little bit larger just to make it easier for the user to actually press on. And then we're choosing what the type of cap function is. So in this case, we're going to use the handles and we're going to use rectangular handle cap. There we go. Now that will add a button, but we want to know which button we're actually going to display. So we'll have to come out of here. We'll add an int and we'll make that nullable. And we'll just put in a variable picked handle and we'll set that to null, because when we start up, when we press on this component, we don't want any handle to be shown. We want the user to select the handle to actually manipulate it. Okay, and in here we'll use picked handle and we'll set it to I, which button we're actually on. Now of course we won't be drawing all of these handles. Instead, this for loop will do if picked handle has value. Has that picked handle been pressed? Has it been selected? And if it has, then we're going to get the control point from the picked handle. So the value that we've actually got. And then also we'll want to set that as the set control point. So just to go over it, we're coming through, we're setting buttons in each of the points. When somebody presses those buttons, we're setting an index. And if that index has been set, we're then showing the handle to display. So let's save that and see what it looks like in Unity. We come back into Unity and now you can see that there's these points available. So now I can press on them and move it. I can still move everything. I can turn off my move manipulator. I can come back and I can move the point itself. This means that the user is not overloaded with tons of handles when they get to show the path. And also when they select a handle, they can choose which one they want to use and they won't be fumbling if they're so far out that the handles are overlaying. And this makes a really good tool. We've made some really interesting design decisions here. We've come in, we've said, okay, this path is going to be both world space and local space. We've said we don't want to manipulate the path using the array because that's really awkward. We want to actually put handles on there. And then we've said, okay, the handles are really busy when there's a lot of them overlaid. So we want to make it show that those handles only show one at a time by putting very small button presses in there. And then on top of that, we've said, if we make that change, we want the undo queue to be able to be operable, because not having undo in operations like this, it should be a crime. And that's why we've added the undo redo queue into this. And those are all the design points I really wanted to go through and all the functionality I wanted to show you within this tutorial. Now, this path, you could use it for navigation, or you could use it to create a spline. We've got control points here. All you would need is a Bezier function in here to draw a really nice spline in the world. So you could use this to set up train tracks. There's all sorts of things you can do with this path. So I hope you found something useful in this video that you could take away from it. And if you did, let me know by pressing the like button so that YouTube can say to other people, you know what, check out this video. And if you haven't done so already, consider subscribing. I'm dropping loads of these tutorial videos, and I'm sure there's something in one of the previous tutorials I've done that you'll find useful. And as always, thanks for watching.